Hey guys, in this video we'll cover setup and installation of the Rgpilot flight controller into the F-35B. This will include things like radio calibration, accelerometer and sensor setup, servo output assignment, and reversing. Now, Rgpilot is quite a bit more complex than the things that I'm going to go over, so if you're not familiar with it, I definitely suggest checking out some extra documentation and resources. But otherwise, I've tried to make this process as straightforward as it can be, so let's get started. The first thing that I'd like to go over is my RC transmitter configuration. Now, Rgpilot is pretty flexible, and you can generally use any RC transmitter and any channel order assignment or switch configuration. But if you copy my setup directly, you'll be able to use the firmware that I provided out of the box without having to dive in and modify any parameters in the flight controller. So let's get started. The first thing to check out is the inputs. You'll notice that I have throttle on channel 1, aileron on channel 2, elevator on channel 3, and rudder on channel 4. And this matches the RC mapping that I've got the firmware set up with. Now I've got some exponential on roll, pitch, and yaw. I've got 60% on the ailerons, 50% on the elevator, and 30% on the rudder. That's just how I like to fly this model, and you can configure those as you see fit. Now on channel 5 I've got my mode switch, and that I've put on a 3-position switch up here on the left shoulder of the radio. And what this will do is toggle between the Q stabilized flight mode, which is just a basic hovering configuration, my customized version of the Q loiter flight mode, which position holds during hover but uses nozzle tilt for forward and backwards flight, and then finally fly-by-wire A flight mode, which is the preferred stabilized flight mode that I like to use for forward flying. You can put this mode switch on any 3-position switch that makes it easy for you to toggle these flight modes while you're flying. Next, on channel 6, I've got the landing gear switch. That's on a 2-position switch back here.
Gear up.
And that's pretty self-explanatory.
Gear down.
On channel 7, I've got flaps on a 3-position switch.
Flaps down. Flaps down.
And that just
Flaps
deflects
up.
the flaperons into just kind of a flap configuration that you might use for slowing down on approach. Finally, on channel 8, I've got an arming switch on a 2-position switch over here on the right.
Armed.
Now, you do need to be careful with switch arming in Rgpilot. Typically, how you'd see Rgpilot vehicles arming is with the rudder stick, so held over here for a few seconds to arm, and held over here for a few seconds to disarm. And you can still use that on this vehicle if you choose. Switch arming is a little bit easier, but the caveat is it won't do any sort of checks to make sure that you're not flying if you disarm. So if you're flying along and you accidentally hit the switch into the disarm position, it's just going to shut off the motors and you might lose the vehicle. So definitely be careful to position the switch in a location that you're not going to accidentally hit it while you're flying. The next screen is mixes. No surprises here, everything's just defined 100% straight through. No sort of special mixing between the inputs at all, that's all handled by the flight controller. In fact, the only thing special that I've defined on this screen is in the flap mix I've added some slowdown just to make the flaps deploy at a more realistic speed. The next screen is outputs, and similarly there's no surprises here. So every output is defined in the same mapping order that we came up with back on the inputs page and again on the mixing page. And then we've got 100% for all of the endpoints, since Rgpilot is going to learn and map these endpoints anyway to the parameters when we do our RC calibration in a later step. Now, I have done some reversing on this page to get the directions of each of the channels into what Rgpilot expects them to be. You can flip them in Rgpilot, of course, but I like doing it in the radio. It keeps it a little easier. So the way I've got them defined here is throttle. The PWM value goes high when we throttle up. Aileron, the value goes high when we roll right. Elevator, the value goes high when we pitch up. Rudder, the value goes high when we yaw right. Mode, it goes high when we flip all the way towards the pilot. So that's the fixed wing fly-by-wire A flight mode. Gear, it goes high when we retract
Gear up.
the landing gear.
Gear down.
On flaps, the value is actually high when the flaps are retracted. So it'll go low
Down.
when we deploy the landing gear. And you'll notice it's going low slowly because of that
Flaps
slow function
up.
that I defined. And then lastly, arm goes high when we arm.
Armed.
So that's it for the RC transmitter configuration. If you're able to copy this configuration, if you've got an OpenTX radio or a similarly programmable radio that lets you order all of the channels, then awesome. If you're not, Rgpilot can be configured to work with pretty much anything, and the wiki for Rgpilot will be very helpful there. So now that we've got this configured, we'll move on to the next step. Now it's time to load the Rgpilot firmware onto our flight controller. I've got a cube black here, but the process will be identical for a cube orange, or for that matter, any flight controller that ships with the Rgpilot bootloader. It will be a different process for boards that don't include the Rgpilot bootloader, like the Maytech H743 Wing. So I'll be sure to link that process in the description and in the builds guide documentation. And the good news is, once that process is complete and the bootloader is loaded onto that type of board, you can use the firmware update process we're about to detail for any future firmware loading. Also, don't worry if you've already installed your flight controller in your aircraft. You can definitely load firmware with the board mounted. I'm just doing it standalone on the bench because it's a little bit easier to illustrate. The first step is to plug in a USB cable between our flight controller and the computer. And I've opened the Mission Planner application on my laptop. This is a Windows application, so if you're running a Mac computer, you may have to use a different piece of software like Q Ground Control. The process for updating firmware will be pretty similar, but you'll have to refer to the documentation for that program to find the specific menus that you need to navigate to. Anyways, in Mission Planner, the place we need to be is the Install Firmware menu in the Setup tab. You'll see here, these are all the vehicle types that Rgpilot supports, and if we were to click on one of these icons, it would download the software version. It's usually the latest stable release from the Rgpilot build server. However, since the F-35B needs a customized version of Rgpilot, we won't be able to do that, and instead we'll use Load Custom Firmware. When you click this, you'll need to choose the rgplane.apj file for your flight controller type that's included with the F-35B digital download. When we select that, Mission Planner will check the file, and then it might ask us to unplug the board, click OK, and then plug it back in so that it can check through the COM ports and see where the flight controller has been connected. So we'll go ahead and do that. Now we'll see that it's scanning the COM ports. There, it's found our flight controller. And now it's erasing the firmware file that's already on the board. Next, it's programming it with the new firmware. And that's it. We see upload done, which means that the customized version of Rgpilot has successfully been loaded onto our flight controller. What I'd like to do next is get the accelerometer calibration out of the way. And that's pretty easy to do. with the flight controller unmounted from the vehicle like this. But if it's mounted to the vehicle already, no problem, you can do it that way too. So with the flight controller still plugged in via USB, I need to find the COM port that it's connected to in the Mission Planner dropdown. Choose 115-200 for the baud rate and click Connect. We'll see a window when the Mavlink connection is trying to download parameters. And then once it finishes, we'll be connected to the flight controller and ready to configure. We don't have any sensors, GPS, servos, or anything plugged in right now. That's fine. We're just going to calibrate the accelerometer that's on board. Let's go over to the Setup tab under Mandatory Hardware, and then Esc Calibration. And then we'll click Calibrate Excel. The first step is to place the vehicle level. We've already got it level. We'll click Next. Now we want it on its left side. I'm just going to get a box here to prop this up since the USB cable's in the way. Click Next. Now right side. Nose down. Nose up. And on its back. And that's it. The calibration was successful. Now I just did that assuming that I've got the flight controller mounted in the airplane upright and facing forwards. The calibration does depend on the orientation of the flight controller being configured correctly. And you can generally mount in any orientation as long as you configure the parameters to match. So a good rule of thumb is if you're not sure which orientation that you're going to mount the flight controller, get it mounted, configure the parameters accordingly using the wiki as a reference, and then worry about your accelerometer calibration at that point. But otherwise, we're good to go and get this installed in the vehicle. The next step is Esc Calibration, where we go ahead and make sure that Rgpilot's parameters align with the stick layout, channel order, and switch configuration that we assigned in our RC transmitter. To do this, we need our USB cable connected to the flight controller installed in the aircraft. We need the RC transmitter and the RC receiver powered up. And then I've got Mission Planner open and connected on my computer. You don't necessarily need a battery plugged into the vehicle to do this because most flight controllers will power the RC receiver from the USB connection. So in Mission Planner here, we're going to navigate to the Setup tab and then to Radio Calibration under Mandatory Hardware. The first thing we need to do is check that the directions of all of our channels match what we set up in our RC transmitter previously. So let's go through the list. For throttle, we want the PWM to increase when we throttle up. For roll, we want it to increase when we roll right. For pitch, we want it to increase when we pitch up. For yaw, we want it to increase when we yaw right. For the modes on channel 5, we want high PWM when we flip the switch into the fixed wing position. For gear on channel 6, we want high PWM when we retract the gear.
Gear up, gear down.
For flaps on channel 7, we want high PWM when we retract the flaps and low PWM when we deploy them.
Flaps down, flaps up.
And finally, for arming on channel 8, we want high PWM when we move the switch to the arm position.
Armed.
Okay, those all look good. Now we can move into the calibration. So we'll click this Calibrate Radio button. It's going to ask us to make sure the transmitter and receiver is on, and that also we don't have any power applied to our motors, and that's the case for both items. Now it's going to ask us to click OK and move all the sticks and switches to their extreme positions. So we'll do that. We'll move all our sticks to the corners, and we'll see these red bars changing to the min and max of each channel. Make sure you do it for the switches as well. So we've got mode on channel 5, gear on channel 6,
gear down,
flaps on
down,
channel 7,
flaps up,
and then arming on channel 8.
armed.
and we're done. Those are all the channels we've got configured, so we'll click here. Once all our sticks centered and that the throttle is down, if that's the case, we'll click OK. And then it'll give us a window with the new minimum and maximum values that it learned for each channel. That looks fine, so we'll click OK. And that's it. Our RC calibration is complete. Now that we've verified the channel order and direction of our RC channels and calibrated the endpoints, it's time to make sure that our servo outputs are configured and reversed correctly as well. To do this, we need the aircraft to be plugged in with battery power, and to make it a little easier, I've disconnected the USB cable and instead connected to Mission Planner using my wireless telemetry radio. That just makes it a little bit more straightforward for us to move the model around without having to worry about yanking the computer off the table. So, this is an area that a lot of people get wrong with Rgpilot. You don't do any reversing in your radio for this step. We're just looking at the responses for our servos based on stabilization inputs from the flight controller. And after those are correct, if any of our manual inputs from our RC channels mismatch, we'll deal with that after we get all the stabilization inputs reversed properly. So to do that, we'll just grab the aircraft, we'll tilt it, and I've rolled to the left here, and we see right roll corrections from the servos. So we've got down on the left aileron and up on the right aileron. So those channels are set up properly. Same thing for pitch. We'll pitch down. We see the stabilators move upwards, and we'll pitch up. We see the stabilators move downwards. So our pitch and roll responses are correct. We don't have to worry about any reversing on our servos. If we did have to do that, they'd be under setup and servo output under mandatory hardware. And on this page we see all of the assignments for each servo that's plugged into each channel. And these assignments match the table that's in the build guide documentation. If for whatever reason you needed to reverse an output, you'd do that here. If we needed to reassign one, or you've plugged a servo in a different channel, we could do that here as well. And then lastly, this is where you set the minimum, the maximum, and the trim position for each of the servos. So once you've got all the reversing squared away, you should change these trim values to level all of the servos, and then you should change the min and max values so that they move to the travel range specified in the build documentation. This is really important because the stock gains for this aircraft are set using those stock travel recommendations, and if you use a different amount of travel, you may have a tuning issue with the stock PIDs. Now there's a few channels that we didn't check out here with the reversing. Of course the motors, however, all ESCs pretty much work the same way. Low is going to be low, high is going to be high. It is a good idea to check out Esc Calibration in the Rgpilot wiki. There's a couple of tricks that you can use to calibrate your ESCs so that their range matches the Rgpilot range, and I would very much recommend that. We've also got the nose steering down there. That you really should use tilt in the same way to visualize. It's tough to tell. There is some yaw stabilization mixed into the roll motions. So typically you'd want to see the wheel rotating in the opposite direction of a roll input. But also we can go ahead and check that with our RC transmitter here. So it's moving right and left as we'd expect it to. This is the right point to check the manual inputs to the rest of the control surfaces as well, since we've already got the control surface reversing set up for the stabilization responses. So we'll see that manual is correct too. If the stabilization responses were correct, but this was backwards, this would be the time to reverse these inputs in the transmitter. And then the last ones we didn't check, of course, transition. of the nozzle, but that's pretty easy too. If we move this switch from this fly-by-wire flight mode into one of the vertical flight modes, we'll see the nozzle back there rotating to the vertical, and then back when we go to fly-by-wire A. The last note is that if you are using the trim, min, and max to do your control surface centering and your endpoint adjustments, you should be doing that in manual mode because the control responses in fly-by-wire don't quite match manual inputs. So we can switch into manual mode in Mission Planner here. And now you'll see there won't be any response to control or to stabilization at all, only to manual controls. So here you'll see the full range of motion of the servos, and you can use those min, max, and trim values to make those ranges match the recommendations in the build guide. The next thing to check is flight modes, and to do that we'll go into Config, and then we'll go to Flight Modes at the top. So here's where we see the list of modes that the aircraft are in, depending on our switch position. So what we should see is when the switch is fully back, it should be in Q-stabilized mode. When it's in the middle, it'll actually be in this blank position, and the reason for that is this is my custom flight mode for position, hold, hover with nozzle tilt, and Mission Planner doesn't have a name for that. So it'll show up as blank, but if you want to verify the parameters, there's a parameter for flight mode 4 in the full parameter list, and the value of that, actually we can look that up here. We'll go to full parameter list. We'll type in FLT-MOD in the search bar. And then under flight mode 4, we see 26, which is the value that I've assigned to my custom flight mode. Of course, these parameters here you can actually move around if you want different modes to be in different switch positions, but that's pretty outside the scope of the setup guide, and you should definitely consult the Rgpilot wiki if you're going to want to try different modes. Anyways, the last flight mode on our switch is the fully towards the pilot position, which puts us in fly-by-wire A for forward flight. You'll notice that I don't have manual on the switches, and that's because manual mode will result in a very abrupt transition if you ever switch to it, and I just prefer fly-by-wire for forward flying of this aircraft. You'll also notice that I don't have return to home set up. You're certainly welcome to do that. The configuration will fully support it, but I would recommend setting up a different switch and then setting the RC option for that switch to RTL, and you can refer to the Rgpilot wiki to do that. You should also check out how quad planes handle RTL, since there's combinations of fixed wing flight and transitions and then vertical landings that you can configure an Rgpilot vehicle to do when it enters RTL as a vertical takeoff vehicle. The last thing that I want to do, now that we're plugged into the aircraft and everything is powered up, is verify the compass configuration. So we'll go ahead into Setup. Then Mandatory Hardware, Compass. What we're looking for here is, in this list of compasses that have been detected, we want the external compass, the one that's mounted to our GPS receiver, to be the first in the list, the highest priority compass. So for me, since I'm using a UAV CAN GPS, the UAV CAN compass is the top item in the list. But if it wasn't, I would have to use these up arrows to move that one to the highest priority, and then click Reboot to reboot the autopilot with the new configuration. And similarly, you'll do the same thing with an I2C compass if you're using a compass that's on an I2C and serial GPS module. Now, you will have to do compass calibration with this vehicle. I won't show the process because it's pretty much just going to be me spinning around trying to hold it with the camera off in the distance. But there's some video guides scattered around YouTube you can use for Rgpilot compass calibration, and of course refer to the wiki for that. That's about it for our quick Rgpilot configuration guide for the F-35B. But let's go over what we covered in this video and what we didn't cover, because this is a complex piece of software, it's on a complex aircraft, and we can't possibly go over all the intricacies in a short video like this. So the first thing that we did was we set up our RC transmitter with channel orders and switch layouts that match what I've been flying on my vehicle and what the Rgpilot parameters and firmware are set up for. This gets rid of all the guesswork for setting up which channel is which and which switches do what. So I really recommend copying my configuration versus trying to figure it out yourself. But if your RC transmitter doesn't let you do that, you can refer to some Rgpilot documentation for how to reorder channels and define endpoints. After that, we got the custom firmware loaded onto the Rgpilot flight controller. And that firmware is mostly off-the-shelf Rgpilot, but I've customized it with a motor mixer for the F-35B, a custom flight mode, but then, very importantly, all of the parameters for this vehicle are baked into it as defaults. So the output order for the servos and the motor, the PIDs, basically everything about the configuration that differentiates it from stock Rgpilot is already done for you. You may have to retune, you might want to tweak some things to your preferences, but for the most part, it's ready to go as long as you build the aircraft as the build guide suggests. After that, we did a quick accelerometer calibration for the flight controller. I did that on the bench, but you can do it in the vehicle as well, and it's mostly moving the flight controller into different orientations so that it can learn the offsets and the extents of the accelerometer. After that, we got everything connected over USB while the flight controller was in the aircraft with the RC receiver. And now, Rgpilot can see the signals from the RC transmitter, and we checked to make sure that all of the channels and the reversing that we set up earlier was matched in what Mission Planner saw from the autopilot. Once we verified that, we did RC calibration in Mission Planner, so that Rgpilot could learn the extents of each of the channels and the sticks and the switches for our RC radio. After that, we verified the directions of all of the servos. So we powered up the aircraft and we moved it around in fly-by-wire A mode to make sure that the control surfaces were responding correctly to pitches and rolls. And if you built the aircraft the way that the guide shows, chances are this is all correct right away, since any sort of reversing necessary is already built into the firmware that I prepared. However, if that's not the case and some channels are reversed, you can use the servo output screen to do so in Mission Planner. You can also put the aircraft in manual mode and use that servo output screen's min, max, and trim fields to set the centering and the endpoint range of all the control surfaces to match the recommended travel in the build guide. Once those were all set up and we knew that the stabilization outputs were correct, then you can wiggle the sticks and just make sure that the manual responses are correct too. However, since we controlled the RC channel directions early on and we set the servo output directions to match the stabilization outputs, chances are very high that once you've done that, this is going to be correct. And that's about it for what we covered. So what we didn't cover, of course I didn't show the compass calibration, you're going to need to perform that. But there's also what if you used a different type of compass or a different type of GPS. You can configure Rgpilot for a UAV CAN GPS like I did here, but if you need to change the protocol back to serial, for example, you can do that in the parameters. And again, the Rgpilot wiki will be your friend here if you've picked a sensor configuration that doesn't match the build guide. Along those lines, we didn't cover different types of RC receivers. So if you've got a Spectrum receiver, for example, that uses SRXL to communicate, you're going to have to refer to the documentation for how to configure Rgpilot to do that. And of course, that's all there in the wiki. There's additional options you can use for FrSky telemetry if you want to get telemetry back to your RC radio that are worth looking into as well. We didn't cover an airspeed sensor. I don't have one fitted to this vehicle, but I should. I've been meaning to add it, and it's a good idea because it can make transitions a lot more accurate when you're flying in situations where you've got a headwind or a tailwind, or really when it's anything but calm. So if you fitted an airspeed sensor, check the documentation, get that configured as the wiki suggests. And that can be UAV CAN or drone CAN or I2C or whatever. There's plenty of different options for that. We didn't cover power modules, which are how Rgpilot measures voltage and current. In my build guide for the cube configuration, I do have the power modules set up, and the firmware for the cube will have them configured in parameters. But if you're using different power modules, if you're doing voltage only, or if you've got a big enough power module to actually measure the current of these ducted fans, you'll have to look at the wiki to figure out how to configure those and accurately get your voltage and current information to Rgpilot. Lastly, we didn't cover tuning. You might not need to tune this vehicle because I've got the default gains baked into the firmware, so if your build is about the same weight as mine, if your batteries are about the same performance, if you've got the same control throws, you'll probably be good to go. But if it's not, you might have some tuning you need to do in the hover mode, you might have some tuning you need to do in the fixed wing mode, and you should refer to the Rgpilot documentation to do this. Now the Rgpilot developers are always hard at work. They've created some new, really convenient tuning methods for VTOL aircraft, and I do plan on making some video guides later for the quick tune process, and then also auto tune for forward flight that I think will be really helpful. And then finally, we didn't go over how to operate an Rgpilot vehicle in general when you're ready to fly. For that, I really recommend setting up real flight, and there's another video in the list for how to do that with the custom F-35B model. If you get that model installed, if you get it set up in real flight and you're comfortable using it and interacting with Mission Planner, the chances are really high that you're going to have a successful result the first time you go fly in real life. And with that, thanks for watching. Feel free to reach out if you've got specific questions about setup-related quirks. I know this is a lot of material to cover, and there's a lot of material that I didn't get into as much detail as I would have liked, so really appreciate the feedback there, and I'll try to address everything that comes in as best I can. Thanks, and stay tuned.